Before I start telling you what amines and amides are used for, you must first know what they are. Amines are compounds derived from ammonia. There are three types of amines: primary, secondary, and tertiary. Categories depend on the number of alkyl chains attached to the nitrogen group. Since nitrogen can form a total of 3 bonds, it will make 1 bond with a carboxyl group and 2 with hydrogens. For the primary amines, the nitrogen groups get attached to 1 carboxyl group. No matter how many carboxyl groups that are in the chains, only 1 will be attached to the nitrogen. This is the model of a simple amine. For secondary amines, the nitrogen group will be attached to 2 carboxyl groups and 1 hydrogen. This is a model of a simple secondary amine. For tertiary amines, the nitrogen group will be attached to 3 carboxyl groups and no hydrogens. This is a model of a simple tertiary amine. To name amines, you must list the names of the alkyl groups bonded to the nitrogen atom in alphabetical order, and then you must put amine at the end of this. To name this amine, you must do the following. This nitrogen atom is attached to a hydrogen and 2 carboxyl groups. These carboxyl groups are methyl groups. This means there are 2 methyl groups. To make them methyl groups, there is 1 carbon in each, and the nitrogen will be what makes it an amine. Since there are 2 methyl groups, this is what makes it a di. So that means it will be dimethylamine. Primary amines have the highest boiling points of the 3 kinds. This is due to their ability to form hydrogen bonds with each other, as well as van der Waals dispersion forces and dipole-dipole interactions. Of the organic molecules, amines are the strongest bases. The primaries are the more basic of the 3. Although they have strong bonds, the bonds in alcohol are still stronger. This is due to the fact that the OH bonds in alcohols are more polar. So now that you know about amines, what are amides? Amides are derived from carboxylic acids. Carboxyl group is also directly attached to the nitrogen atom. Carboxylic acids can react with ammonia or with the primary or secondary amines to produce these amides. Amides are similar to amines except for the fact that there's an oxygen attached to a carbon. Proteins contain amide bonds called peptide bonds. The breaking and forming of these are what gives the specificity to the proteins and their functions. Amides also have 3 forms: primary, secondary, and tertiary. Just like the amines, the primary version of the amides are determined by how many carboxyl groups are attached to the nitrogen atom. This is a simple model of a primary amide. Secondary amides are determined also by the amount of carboxyl groups attached to the nitrogen atom. In this case, there will be 2. Tertiary amides are characterized by the fact that there are 3 carboxyl groups attached to the nitrogen atom. To create amides, condensation reactions must occur. This also creates water. Nitrogen makes 2 or more bonds to the hydrogen or alkyl groups. Amides are generally solid at room temperature. Their melting point is high for their size because they can form hydrogen bonds. They need reasonable amounts of energy to break, so their melting point is high. Amides are weak bases. Amides are insoluble in water, however, the smaller chains are slightly soluble. This is due to the fact that there is hydrogen bonds between the amides, polar NH bonds, and water molecules. Now that you know about amines and amides, you can now learn about the real-life applications of each of them. Dyes. Primary amines react with nitric 3 acid to form diazonium salt, which can undergo coupling reaction to form azo compounds, which are highly colored. This is widely used in the dyeing industries. Amines can be used for removing CO2 and H2S from natural gas streams and refinery process streams. Amines can be used to create drugs such as antihistamines for allergic disorders, tranquilizers that don't induce sleep for anxiety, decongestants, things that are named controlled substances by the DEA such as methamphetamine. Acrylamide and polyacrylamide are two amides that are used for many different things. Acrylamide is a carcinogen and is not intended for consumption, therefore it is used for things like pencils, ink, crayons, rubber, adhesives, soaps, explosions, a coating on many household appliances and car parts with thermosetting acrylics. Polyacrylamide is used for things like paper because it is a good binder and retains color pigments. It is also better for consumption, so it is used for things like water and sewage treatment. Thank you for watching, and I hope you learned a lot about amines and amides.